Welcome 7th graders to Lesson 8, Session 3, which starts on page 159 in your book. And yesterday we were adding positive and negative integers. Today, no integers. Well, maybe some integers. But in addition to integers, we're also working with negative fractions and negative decimals. So we've expanded from integers to rational numbers. And our, try it here, says, on a cave dive in Oahu, a scuba diver swims at an elevation of negative 20 3/4 feet relative to sea level. She notices a sea turtle above her and rises 6 feet to take its picture. At what elevation does the diver take the picture? So basically we've got negative 20 3/4 plus 6. So you can solve that however you think you want to solve that. Go ahead, give it a try, see if you get the same answer I get after you pause, try it, and then come back to me. Okay, you did it, you paused, you tried it. Okay, let's see if you get the same thing I did. I'm going to be a filthy cheater, and I'm going to decompose this negative 20 3/4 into a negative 20 and a negative 3/4. And then I'll have my positive 6 over here, because it's pretty easy to subtract or find the difference between 20 and 6. So the difference between 20 and 6 is 14. And the larger number is negative, so my answer will be negative. I go with the sign that is for the larger number. 20 is larger than 6. And then I've got my negative 3/4. So I'm just going to stick that back together. Negative 14 3/4. And what was that? Was that feet? There we go. You can just split. You are allowed to split mixed numbers like that if you want to. All right. What methods did they use here? They used a picture it, which is basically just a vertical number line, since she's swimming up and down. She's swimming around. Yay. Now it's a picture it. Wait, what do we need to draw? We need a sea turtle in there. Now it's a picture it, because it's got all the details on it. Okay, or you can break apart the mixed number. Oh, look, I did that. So we did the second one. Oh, there's the sea turtle. Okay, number 1. Look at the picture it. At what elevation does the diver take the picture? We determined that was negative 13, nope, 14. 14 3/4 feet. And then how does the picture help you understand that the elevation is negative? She is still below sea level. And sea level is what we consider 0. Okay, look at the model. So the second one now. Suppose that the problem uses a decimal instead of a fraction. Actually, since I want to be consistent, I want to keep that negative red. How could you use this strategy? So instead of splitting the 20 3/4 into negative 20, negative 3/4, that's so tiny. We just split in a negative 20 and negative 0.75. It's the same thing, right? The sum of negative 20 3/4 and negative 12 1/4 is negative 33. How can you break apart the mixed numbers to find the sum? Let's see. Do we want to write this out like the book has it, or do we just want to do it? I think I just want to illustrate it. So what we would do is we would take the negative 20 3/4 and we put negative 20, and we put negative 3/4. Oop. And then we'd take the negative 12 1/4 and split it with the whole number, and the fraction. Now we've got to combine these. These are, let's see, 20 and 12, that's 32. But it's all negative, so that means the whole thing's got to be negative. It can't just magically be positive. And then if you have 3/4 of a pizza eaten, and somebody comes along and eats 1 more fourth, how much of a pizza is eaten? 1. But they're both negative, so it's -1. So we've got now -32 and -1. -32 plus a -1 equals -33. So we cheated and illustrated it instead of writing it out, but whatever. I think it's beautiful because I got to draw a pizza. Number 4, how is adding positive and negative fractions or decimals similar to adding positive and negative integers? So remember, integer, that's going to be the non-fractions and decimals. That's the whole numbers, positive or negative. And how is it different? Well, we can't really use integer chips, right? You're not going to get a hammer and break your integer chip into fractions, but we did use the number line with both. They are similar because you can use a number line to find the sum of both. I always forget number lines, 2 words. To find the sum of both. They are, I want a new line. They are different because you have to think about fractional units, which aka, parts, fractions, decimals, not a whole number, as well as whole units. So I want to be sure to illustrate that since I used a lot of vocabulary there. So nope, not the highlighter, wrong one. -20 and 3/4. This is the whole unit, and this is the fractional unit, in case that wasn't clear. Alright, and number 5 is for you to do. Think about all the models and strategies, then all the things that we said and did together, and describe what part of this lesson helped you better understand how to solve the try it problem. Pause, answer the question, and then we'll practice together. Okay, you did that. You paused. What is this? Okay, we got a potion going on. Number 6. A chemist has a mixture with a temperature of 3.5 degrees Celsius. The chemist cools the mixture on this very cool looking ice pile, and the temperature changes by -14.2 degrees Celsius. So it went down by that much. What is the temperature of the mixture as it cools? Show your work. Ooh. So I am going to find the difference between the absolute values of these two numbers. That's what I'm going to do first. So I'm going to just subtract and find their difference, because remember, when I say find the difference, that means do subtraction. And when I do subtraction, since I'm finding the difference between the absolute values, I'm not going to worry about the sign yet. So I'm going to cheat and use this method instead of using the split up method. I guess I could do both, but I'm not going to right now. Okay, keep your decimals lined up. Borrow there. 12 minus 5 is 7. 3 minus 3 is nothing. 1 minus nothing is 1. And then I keep my decimals lined up. So there's my decimal. Now, I go back and I look at which number is bigger. And that's the 14.2. 14.2 is bigger than 3.5. Not negative 14.2, but 14.2 is bigger. So I'm going to use the sign that goes with the bigger number. It's negative. So its new temperature is negative 10.7 degrees Celsius. Okay. This one, I don't like splitting up the decimals as much, but I do like splitting up the fractions. So let's split up these fractions into... We're going to decompose the -12 and 3/4 into -12 and -3/4. And then we're going to decompose the negative 5½ to negative 5 and negative 1/2. And we're going to combine all of these terms. So we've got 12 negatives and 5 negatives. How many negatives is that altogether? That's going to be 17 negatives. Now we've got to combine 3/4 and 1/2. So I will show that work over here because I don't want to ditch you guys if you can't do that in your head. Negative 3/4 plus negative 1/2. So we're combining these because they're both negative. And if you recall, in order to combine, in order to add and subtract fractions, we need a common denominator. So we need this 4 and this 2 to somehow be the same number. Well, the easiest thing's going to be to change this 2 into a 4 by multiplying by 2. But if I do that to the denominator, I also have to do that to the numerator. So this fraction is now 1 times 2 is 2, 2 times 2 is 4. This fraction is now 2/4. So I'm going to rewrite that one more time. Negative 3/4 plus negative 2/4. 3 and 2 is 5. And then the denominator will not change at that point. So I have negative 5/4. Oof, more steps. Not done. Because now look what we've got. We've got a larger numerator than the denominator. If the numerator is larger than the denominator, it's an improper fraction, and we don't want an improper fraction. We always want to be proper. And always remember, you can also think of a fraction as a division problem. So this is just 5 divided by 4. How many times does 4 go into 5? It goes in 1 time. And what is the remainder? The remainder, it would be 1, and we just keep the denominator the same. We're going to keep that, keep that 4 down there. But remember, it's still negative. Don't forget it's negative. Never forget it's negative. So we have negative 17, and we have negative 1 and 1/4. We're going to stick these back together. But in order to stick these back together, look at this. Negative 17, negative 1. What's that? Negative 18. And then I'm going to stick my negative 1/4 back on there. There we go. Okay, one more. Let's see. Do we want to split this one up, or do we want to do it finding the difference? Choices, choices. I think I'm going to do it the first method because I prefer that when it comes to decimals, personally. So we have negative. Nope. What am I doing? Going crazy. Negative 2.75. I want to put that on the bottom. You can do that now. You can't. I know you can't usually like put subtraction problems in whatever order you want, but when you're using this method, you can. So I just need to find the difference between these two numbers. So 5 minus 5 is nothing. 2 minus 7, I do have to borrow there. 12 minus 7 is 5. Keep my decimals lined up when I'm subtracting decimals. 7 minus 2 is 5. So we've got 5.50. Now the reason that we can decide which number goes on top, we can do whatever we want, is because for this method, now we're going to look which of these numbers is bigger. And it's obviously this one. And is that positive or negative? It's positive. Therefore my answer is positive. We use the sign that goes with the bigger number. So this one's 5.5. Okay, that's it. Good luck.